All right. Hey, y'all. Space Miner checking in. So here's the short and skinny. Today, I'm going to be making some gallium indium eutectic. Okay. And, oh, I just plunged it. There we are. Okay. So here's the deal. I'm over at my buddies and I say, I'm going to make some of this eutectic. Okay. And the deal is I don't want to weigh gallium on his scale. Okay. Speaking of scale, we'll need that here in a second. So everything I have comes in like 100 gram portions, pretty much. So like this was 100 grammer. That's 100 grammer, right? And so I needed to figure out, okay, for my eutectic, I'm going to need 75.5% gallium and 24.5% indium, okay? And so the deal is I have to actually crunch the math for that if I don't want to cut my gallium. Originally, I was like, okay, no big deal. I'll just cut off 75.5 grams of gallium, and then I'll cut off 24.5 grams of indium, okay? And then I was like, I don't want to cut the gallium. So now I got this random sized chunk of indium and definitely 100 grams gallium, okay? So I just wanted y'all to see how this math kind of works. Can I borrow you and your calculator and scale, please? Okay, thank you. All right, so we're going to see. Now, guys, I'm not paying extremely close attention to any chat, so I'm sorry if I miss anything. We're just kind of moving with a purpose at the moment. We're in a bit of a time crunch because the gallium's in hot water, okay? So we have 58.8 grams of indium. So what I'll be doing is I'll be cutting this down until I reach 32.45 grams. And so let me show you real quick how we get to that. Okay. I'm going to set this aside for a moment. All right. So what we'll do is we'll take, we know that we have 100 grams of gallium, and we know that that is 75.5% of the total alloy composition, okay? So we're going to divide by 0.755, okay? This is 75.5, okay? Which is going to equal 132. Okay, let me divide that by the 0.755 equals the 132.45. So now we know that the total alloy at 100% is going to weigh this much. So then it's pretty simple. We just minus, and we'll double check everything, right? We'll just minus 100 grams, which is the gallium, okay, which will leave us a remainder of 32.45 grams of indium, okay? So now my goal is cut 32.45 grams of indium up and prepare it for the eutectic alloy, okay? So, double check that. 57, all right. Indium is extremely soft. Like, here, where's that? See that cutting right in? Okay, it's extremely soft, so what I'll do, I'll put me down a little temporary cutting board, which is...
West Texas Stacker says gallium is 180 a gram.
Yeah, life's fun. Yeah, but I called this video Gallium Gain, okay? Gain is kind of a joke, you know, it's like gallium indium. It's the chemical names of gallium and indium, gain. Okay. And that's the alloy we're ultimately building. Okay. But let's see what we got there. Okay. We need to come down another 12.1 or 10.1, 12.1. Okay. So, yeah. We're going to make it, but also we're going to gain in value by doing this work. Okay, guys? And this is like where premiums come in with these 39.2. Dang, we're going to keep on going.
Joseph Lopez says hi.
Hey, Joseph.
Happy Tiger, that laugh.
Keep going. Can you guys see what I'm doing? Sorta. No, probably not that well. I'm trying to. 34.2. What did we need to get to? 32.45. Okay, let's just cut a corner off real quick.
WC coins, gallium.
All right. Hopefully you were there for the math to double check me, Dub. So for all those that are late to come in, all right, 32.5. What did we need to be? 32.45. I'll take 32.5. You know what? Let's shave hair off. We're not going to get all of our gallium out of there. And I don't know what my exact total weight of gallium is. So the goal was to get to 32.45 gram. We're at 32.4. 30. It was weighing 32.5 a second ago. Close enough. You can always adjust those grams or micrograms at a time. So again, quick refresher. We've just been waiting for the gallium to get soft in the hot water. Okay. We had one more time. I did not want to cut the gallium up, man. I didn't want to cut it up. I didn't want to weigh it. I didn't want to do anything with it. I know it's 100 grams. Okay. I knew this, but I didn't want to put gallium on his scale. You know, my scale, I'll take necessary precautions. I just don't want to risk it with his scale. Okay. And so I didn't want to mess with the gallium. I had 100 grams total, but the composition of your gallium indium eutectic is 75.5% gallium and 24.5% indium. Well, if I don't want to change my gallium measurement, because again, I was just going to put 74.5 grams in, or I mean 75.5 grams in. That's originally what I do. 75.5 grams and then 24.5 grams of the indium. I didn't want to change this. So I said 100 divided by 0.755, okay, gives me a total weight of 132.45. We already have 100 grams of that weight accounted for, so we remove it, leaving us a remainder of 32.45. Okay. And then that 32.45 is in fact our indium measurement. So now that we've got the indium measurement, we had to cut down on a random size chunk, okay, until we hit our, see now it's saying 32.5. Here in a moment, it might say 32.4. That means we're probably pretty close. I could probably adjust the units, but this is fine for the cause, okay? Now, here comes the fun part. Gallium's freaking messy, guys. Like, no joke. Now, everything here is completely safe, non-toxic, stable element, okay? So we don't worry about any biohazard in this. But what you do worry about is stray gallium, okay? The last thing you want to deal with in around any aluminum is going to be stray gallium, okay? So you don't want this to splatter. You don't want this to creep, okay? Couple other neat little features about gallium. Gallium, unlike most metals, okay? Gallium, when it gets cold, when it freezes, okay? You know, and all metals got a freezing point. Oh, man, I hope this is warm enough. I don't think it's warm enough. We're gonna take just a second. I don't like how it's not freezing enough for me. I mean, it's still showing some signs of freezing. So gallium, whenever it gets cold, unlike most metals, they shrink, right? Like anybody that's done any garage mechanicking knows, when the parts don't fit, you freeze one and heat the other, right? And they usually fall right in, okay? Well, gallium expands whenever it freezes. And it's got a pretty significant expansion rate. It's like 3% or something like that. Which is it's crazy, it's nutty, and then you start like looking at like different hydrodynamic principles and like different grain boundary principles and stuff. Well, we're not going to get into that. It's cool. It freezes. So what you don't want to do, what's that?
Do it in a large container.
Yeah, I'm thinking we're going to. Where was what you don't want to do is keep it in glass, okay? When it freezes, it's going to expand against that glass and it's going to fracture it. In fact, I was thinking about using this guy, but I don't know if you can hear how hard that plastic is. That was enough for me to have concerns about like microfracturing and creeping. And so I really didn't want to get into that, even with like a hard plastic. So really just something. Usually all your polyplastics are going to be good for the job. Okay. You don't want them to break, bust, fracture, shatter, things like this. Okay. That's the simplicity of it. All right, here's the deal. We're losing heat on the water, which means we're going to lose a little bit of heat on the metal. We're just going to go for it, see how far we can get. Okay. We did the math. Everything should line up. Okay, here's one of these moments I'm talking about, okay? It's one of those stupid pop tabs. I hate these things, but there's a reason they put it in the pop tabs, okay? But anyways, we don't want to like pop gallium all over the place, okay? So small, like here, you guys see it? Blip, 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 blip. Blip, 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 blip. You hear it? Blip, 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 blip. No, I'm just kidding. But we're not going to pop this and fling gallium all over. We'll just do a little cover. No big deal. We'll work over something. That's another one. Originally, I was going to go for the pour. And then I was like, oh, stupid. That's a shampoo top. That'll pop right open and squish, squish everywhere. So I don't want to do that. Okay, that's clean. Just make sure you guys can see it. See that? Bloop, 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 bloop. Okay, and when that gets cool, it'll freeze. Come on. Now, it's got a pretty high surface tension, so you don't have to worry about like splattering so much as like popping metal, throwing metal, flicking metal. That's really the bigger concern. But like splashing is not like really a thing with this. It's kind of fun. You can like drop it from a pretty good distance and it'll be like bleh, bleh. So when you're pouring it, don't worry too much. That surface tension holds it pretty well together. Okay, we're going to close this. Okay, and hey, brother.
Yeah.
Would you please open up that cap so I can put that in there?
This one here.
We're not losing much, y'all. We're not losing much at all. Maybe, a quarter of a gram.
Might be able to reheat it.
Yeah. Yeah, I'll recover all this later with other methods, so it's not a big deal. All right, so it's still nice and liquid, right? There we go. Boop, 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 boop. Now, gallium wets everything, y'all. In fact, it's one of its major industrial applications is wetting. Okay, they'll wet a pane of glass or some type of material, right? And it creates a reflective layer, because it's wet, and so they'll put it on a pane of glass. In fact, when you guys are talking about solar panels and silver, well, you need to be talking gallium too. A lot of your single layer, or like a crystalline layer, they use gallium to wet it. Okay, for reflectivity, and then it's got some other principles that aren't too important. Okay, so here's this. I should have saved a block of it in solid. If you got two pieces and rubbed them together, eventually they start wetting. Let's see. All right. Trying to work above the bowl and not get my fingers messy. Honestly, I don't want to get it on my fingers right now. But right now, this is forming a liquid alloy at the surface. So we're just going to drop it in here and smother it. Okay. Bloop, 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 bloop. And then a little bit of pressure contact won't hurt. Here. As I push it like this. Okay. Eventually, it starts eating it. And I'll show you what I mean. Oh, down here. See this? Right here happening? I don't know if you're seeing this right. See how it's like kind of coming up? Isn't that cool? Isn't that nuts? See, look, it's just forming little puddles and stuff. All right, that's enough playtime with that. Try to get it off my fingers. Look at this. See, it just freaking wets everything, dude. You can kind of break some of it off, but like, it is messy stuff. Like, the best thing to do, get it cool. That's the best thing you can do for it, cool it. So, a little bit of air action or something, blowing on it. It's the cleanest way to get it off. And then when I'm all done, what I could additionally do is like wipe my hands with aluminum foil and then bag up the aluminum foil. That way it doesn't, contaminate other things. And that's like one of the best ways because they'll amalgamate. And just makes for a cleaner environment. So, come on. Now this might end up taking a minute, dang it. And see how it's wet and everything? Blup. Oh, that's still hard. See, that hasn't quite alloyed yet. Yeah. And, oh, there we go. But eventually, ooh, it's starting to build up warmth right now. It's getting warmer. Has like a little bit of an exothermic reaction. And see how it's wanting to stay liquid longer, And as more of this liquid alloy strokes over more of this liquid alloy, it'll alloy with that, and eventually we'll recover all of this, and it'll just want to stay liquid. The goal here is I'm making gallium indium eutectic. It'll be at room temperature. It'll stay a liquid metal like mercury. It's used in like thermometers and stuff, but I'm going to use it for hydrogen production. I'm going to react some aluminum with it. I'm going to let it alloy with aluminum, and then it'll break the structure of the bonds of the aluminum, and aluminum loves to react with water, right? It loves to react with water, and so when it reacts with water, all the aluminum, once it has its bonds broken by the gallium, it'll release, when it reacts with the water, it'll release hydrogen. And so I'm using it to put aluminum in it, pour some water in there, and it'll react and form hydrogen gas. And then I'll use the hydrogen gas for other purposes, like hydrogen's really freaking hot. It's a really hot burning gas. So look at that, how long it's staying. And I'm telling you guys, this, we're outside in like a shed, like a garage shed thing, and this should have been all frozen by now, which means tons of it has already reacted. Look at it breaking in pieces. I don't know if you can see that yet. It's really reflective stuff. Lop. See, this should have been long frozen by now, but it's not. And it's generating a little bit of heat. And it's just forming a gain alloy, a eutectic alloy. And eventually it'll be all liquid. Blip, 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 blip. And then I'll put aluminum into it. I'll let it alloy with the aluminum, or contaminate the aluminum, or poison the aluminum, whatever you want to call it. And then I'm going to take these gloves off for a second. Don't look at my wet hands. It's normal. Everybody does it. All right. So now I'm just going to do nothing. The whole point was I really needed to show you guys while the water had the metal warm enough to pour. And that's it. Now I'll just do nothing. I'll just wait. Eventually I'll come in and, oh, thank you, bro. Eventually I'll come in and scrape it around a little bit and get it mixed in better. And then that's it. Then next time I play with hydrogen, or we play with hydrogen, if you guys want to watch. But so here's something neat. Last time I priced 10 grams of gallium indium eutectic. It was nearing 200. It was like 197, 198 or something like that for 10 grams of eutectic. And we will have a total of 132.45 grams. 132.45 grams of eutectic. And this is what it means to gain. See, get it? Science jokes. Oh, I'm such a dad. Anyways, can't help myself. But yeah, so I'll be raising the value of this. And then what I'll do is I'll come in. I probably won't be like this, but maybe use like a more medical style syringe, fully plastic, and I'll capture it, I'll capture it 10, 50, 100 grams at a time, bloop, and then that stuff's going to be worth, 10 grams worth near 200. And if I do a little bit of extra work, do some extra cleaning and refining, then I can take this up to 5, maybe 6 nines pretty easily. 6 nines is not easy by any means, just so you know. Yeah, you guys see that bubbling? I don't know how to. There's like tiny little bubbling going on in there. It's because it generates heat in the chemical reaction. Something's got to give. So anyways, gallium gain. I just gained value with my gallium and my indium. I can make a whole bowl full of this, but we're just going to make some to get through a couple experiments with hydrogen and then probably move on to something else. I don't know. We'll see. But I just bought a kilo of the stuff, so let's put it to work. All right. Okay. Yeah, heating them up would be great right now. And then Frisk, didn't you mention there was another acid I could toss in there, like an acetone or something like that? Probably help me out with that that mild oxidation on the surface. So what'd you guys think? Now look, I'm looking at you now. I'm not doing stuff over here. I'm looking at you now. How'd it go, guys? Was that something you interesting, different for the day? I know not everybody's, doing this live. At least I don't think so. I don't know. I know Dub wasn't doing it. Love you, Dub. Guys, got any quick questions? I don't want anything to do with Bill Nye the Creep guy. Jeez, that guy's a nut. Hey, MSJ, good to see you, buddy. Let's see. You use an excess of gallium and what is not eutectic, and the leftover gallium will be left over to get rid of the oxide layer. You can use HCl vapors. Oh, right, hydrochlorine vapors by setting up a cup of hydrochloride next to it under a larger bowl. Okay. So we'll use the vapor for the surface of the oxidation layer, for that surface oxidation layer. Cool. 79, welcome in. Frisk, good to see you, by the way. Thanks for jumping in. You're the perfect guy for the job, huh? Look at it, bro. It's melting. Yeah, it's 75.5 gallium, 24.5 indium. I'm not sticking my hands in it, mixing it around right now. I just want to kind of keep my hands clean. So I'm just going to be patient. It's not going anywhere anytime soon. I can be patient, right? But that's the point of it. I'm gonna use this later for hydrogen production, just small amounts of it, but enough to probably run like a small little hand torch, definitely like a lighter. I could run it probably like a lighter for a while. Later I'll work on other stuff on how to, get better pressures and volumes and things like that, but one step at a time. Oh, I have that other jar. We could pour some distilled in there, take it outside, pour some distilled and watch it fizzle. Yeah, I have another jar over here. Here, I'll just show it to you. Yeah, remember how I said don't put it in glass? I still mean that, but this is in glass, okay? So, this is funny. This, I was just kind of piddling, tossing some scraps of gallium in there to mess with it, in glass. It wasn't enough to fracture the glass, okay? It was just, wetting, enough to kind of wet stuff. And so I threw in some aluminum in there to infect the aluminum, right? Some pop tabs. And over time, it started alloying the tabs to the gallium. And so I was like, okay, maybe I'll toss some indium in there, right? These bigger chunks. I was like, okay, maybe I'll toss some indium in there. Maybe I can force a reaction, force an alloy, but everything's covered in the oxide. You see that white? And it's where it's extra gray and almost fuzzy looking. Okay, so it won't react with it. So my thought going for this was to see if I could react it with the water alone and use the exothermic heat to actually bring the gallium up to temperature, like a liquid temperature. So as it eats the aluminum, it should be dispelling of the aluminum and dropping the gallium. And if there's enough gallium and enough heat in place at one time, I should get liquid gallium pools. The indium should drop into the liquid gallium, force the alloy, and force the eutectic. A eutectic is pretty much just like an alloy that's going to bring down the melting temperature of one. Like, see, gallium melts at one temperature, indium melts at another. You put them together, they melt at a brand new temperature, and most frequently a lower temperature for these eutectics, right? And so now both of these will melt at a lower temperature. So the idea was to put some water in here real quick, react it, just let the hydrogen gas go, and let the aluminum, let that aluminum oxide fizzle out, and separate the gallium, and maybe react the indium all in one go. What do you think, Frisk? Can I do it just by pouring water? The jar's cold, the metal's cold, the water's most likely cold. You guys think we can produce enough heat to turn this into liquid? I'll try it. I'll go outside and do it right now. We'll pour water all over this thing. We'll slather it in water and watch it fizzle and bubble. Want to do it? You got your distill in here?
Yeah, it's right there.
All right. Oh, look at that. See that jar tipped over and it got some in there? See, I can only pour some of this out. So what we'll do is we'll just put it all in here. Come on, thing. There we go. We'll just put it all in here. Open her up. There we go. See all the scraps of everything? We'll just slather water over everything. See what happens. What do you guys think? All right, can we see it? All right, where's that water? Right there. All right. You guys ready? Give me a thumbs up if you're there with me still. Otherwise, I should just do this on my own. Just kidding. You know what? Just in case. Just in case.
Fair enough.
In case I gotta like address something in a hurry. Putting on gloves. All right. Okay. Here, I'll try to work around you guys. Ready? We'll start with just a little bit, see what it does. Let's go with a little more. All right. Wow, that is dirty right away, isn't it? I need to find something here. Where's my metal? Oh, I got too much going on. I'm gonna put that on all the way. What's up?
Wait to the water.
Is this?
No, wait to the water.
Where is it? Oh, right there. Thank you. Thank you.
Yeah.
You guys see that gas forming? Oh, I got tissue right here. I shouldn't use this one. Look at it go. That is dirty. We should add some more water to it, huh?
Just a little bit.
See if we can get some clarity into this. I tried to leave a little bit of room in the top. If anything goes wrong, I'll just pull the lid off the blue and set them in there. Wish I could see my chat. Don't add more water. There's a lot of aluminum in there, man. This could... I might have done too much. I might have to dump it all into the bigger vessel. I'm just hoping I can get it warm enough that I can dump it all out. That's like the real goal here, is just get it out. You know. They went through a little bit of crushing the other day, minor crushing on the surface. Like me trying to like see if I could like free it up. Yeah, it's already starting to warm up. Not too much yet. I mean, this wasn't like frigid cold, but it was cool. It was cold. Yeah. I mean, I'd light it on fire if I didn't want to, you know. Yeah, maybe if I can find something to stir it with real quick. Here, stand by. I'll be right back.
You're gonna light it. I gave it a shot.
Here, this will be my super approved science stick. Look at it, it's floating up a pop tap can on the top. Doop. Oh yeah, look at that. It's like a fizzy drink when I stir it. It's not getting much warmer right now. You know, suppose I could dump it off and just give it a fresh spritz water. Oh, look at that. It's starting to... Look how dark that is. Isn't that fascinating? This is the stuff I need to know before I keep going forward with my other projects, you know? Like, I need to see this actually happening in real life, real time. Yeah, I agree. We should have got a lot more. It should have been like a full... Here, I'm going to dump this water off. I'm going to dump this water off. Okay, and then I'm going to try this with a fresh batch of water in there, and we'll see if we can force a second reaction, you know, which will tell us, you know, if it was just some mild surface reaction that we're witnessing, you know. So let me go dump this. Ready. Sorry, the stick has to stay now until I do something with it. I owe you a bottle of distilled. Well, it's cleaner this time. There's probably some stuff that didn't, you know, like I'd have to like really rinse it, I guess. But give it a minute. Look for anything. I just want to see if anything's like reacting like right away. Got a little bit going on, not much. It could just be trapped gases, you know, finally finding their way out. Yeah, now guys, keep in mind this is just a bunch of dirty stuff that I've played with like a whole bunch. This is like the end of my play junk. All of this, it's just like junk I've been playing with, and eventually I'll clean it, you know, in a much better fashion. No, I don't think it did either. You know, they were just kind of chucked in there. I was kind of curious if you could just chuck them into, you know. Some of them were scratched, some weren't. You know, there's a lot less of them than there was. Some of those disappeared right away. Some of them kind of broke down a little bit further. Like, look, this one's like missing like a huge chunk of it. But some of those, no, they didn't get all the way through, did they? Like, there. Oh, rip my glove. Oh, no. I'll be fine. Yeah. So there we go. It did not react like I wanted it to react. Now I wonder if I just left it in the water as is. I wonder if it would like just stay that way. Yeah, see, these got a lot of composure still about them. You know, they did not get fully infected. Some of them are still shiny. I mean, isn't that crazy though, guys? Like, aluminum wants to react with the water so bad, but not its oxide layer. And this is how aluminum is protected, and titanium, and a lot of these. It's huge portions of this, not to the metal itself. It's not that the metal itself is so safe against these things. It's that layer that's on top that's reacted with our oxygen, and our hydrogen and stuff. These are the tough stuffs. These are the things that they're using in these industries and sciences to... Yeah, look at that, how hard that is. It should be just absolutely disintegrating. So, yeah, that pretty much does that for me. What I'll come in and do is just come in and grind the schmezo out of it. I might just break the glass open, just smash the glass into bits, and then load it with a butt ton of gallium, and then react it through a screen, and maybe that would get rid of a lot of my glass particles. I don't know, this could be a fun one for me to figure out. I mean, there's a lot of ways we could deal with this, but I was just seeing if we could just do it with just water. Oh, I would have loved to have seen that happen. Like everything to just go push and stuff start turning into liquid metal in front of us. That would have been great. If I had been more prepared, it would have looked like that. If I had like prepared a vat of something, I bet you we could get it to look like that. So there it is. I'm going to just call that one where it is for now. Yeah. We might have got more heat if we had used less water. If I had just kept it at a splash for a little bit, maybe we could have got more heat out of it. Yeah. If I had scratched the tabs more, like really ground them in it. But see, the tabs were there to get the gallium out. Ultimately, like I had gallium wet all over this dang thing. It was just like sloshed all over this glass thing. It wasn't enough to like fracture the glass, but it was enough that it was all over it. So I added a bunch of aluminum tabs, right? And some heat and some aluminum tabs, and like kind of used them to like I shook it around in there real good, and eventually got a lot of it down to the bottom, either by just like flaking it off or it dripping off or reacting off. I don't know. I was just trying to get it all to the bottom, and then I added a little bit more gallium in there to try to like accelerate the effect, and then I thought, let's add some indium in there, see if maybe we can force a reaction there. And now I'm adding cold water, seeing if we can force a reaction. I'm trying to go about this the most caveman way I can think of. I mean, this is kind of how sciences were built in the first place. Just guys trying to figure it out, So anyways, that changed, didn't it? And we still have liquid, even under this cool temperature. So, given enough time, I think this will, as long as I got the right amounts in there, this should all take over time as I stir it, mix it later. I'll put more attention into it and force more out of it, force more surface area into it. And then we'll have a pretty decent amount of it. But the fact that we still have liquid right now in this cool temperature says a lot to me. Says it's working. So I like that. Got a little bit of leftover indium for future fun. I don't know if I had to just throw it in for shits and giggles. But what up, noob? But that's pretty much what I wanted to capture. Pretty much. So now I'm going to clean up a mess, and I'm going to come back to this later, probably in some greater volumes, make it more fun to work with. Just, I like more metal. That's what I'm thinking. So a little bit of time, keep sloshing it. Whatever wants to mix will mix. Whatever doesn't will drop or phase out, or what would it be? A phase? It would phase out of it. Creep. It's like a oversaturation almost. I don't know what you call that exactly. I think it's... But pretty neat stuff. You know, look, guys, I don't have to know everything about it in the world. There's guys that know shit tons about this, use it every day, and their industries are totally relying upon it. So, that being said, as an investment, it is not in the same kind of a thing as you'd want to invest like silver and gold. It's not the same thing. It's not the same metal. It's not the same performance. It's not the same market. But man, my gallium has gone up crazy in price. Gallium's going up, indium's going up, and therefore eutectic is going up. You know, which means it won't be long before your solar panels and phones are going up, and LED lights are going up, and oh my wordy, it's all going up. And that's why you're either going to own something or you're not. You're either going to know about what you own or you're not. I just want to make a little bit more out of what I have. I had two valuable metals, and by alloying them, putting in a little bit of work, I have added premium. I've added value. And you know, this is what steel does, you know. They add a little bit, put in a little bit more effort, know the numbers, know how to crunch the numbers, and they gain more value. And then somebody comes in and adds another part, and they gain some value. And then they add a form and gain some value. Then they add a function and gain some value. And you just want to find yourself somewhere in that value ladder, you know. And so I'm going to, like I said, I'm going to clean some of this up and push this around with a stick and stuff. Next time, use the eutectic mix on the aluminum. Yeah. This is ultimately going to power like my hydrogen generation for the aluminum. So I'm thinking some really good scratched up aluminum dropped into this should have like maximum surface coverage, you know, compared to just like tumbling against rocks, you know. And so I'm hoping that I'll just get more surface area, more reaction area out of my aluminum in the future with this solution. Or not solution, alloy. So there it is. That's my purpose. Hope you guys learned something. Not much, but something. And I'm glad you guys all stopped in to hang out with me. I'm going to be messing with this stuff a lot anyways. So expect another video on this, maybe doing something different. Maybe I'll wet some glass and, you know, make some mirror, something like that. And then go from there. So anyways, yeah, any heat's gone. All right. So anyways, with that being said, thank you guys for coming in. Appreciate you. Frisky, good seeing you. MSJ, who else we got in here? Y'all, how do I see my comments? All messages. There we go. Noob, thank you. Cat, good to see you. Looks like that's all my talkers. Appreciate you guys. 79, of course. Blisters, my man. All right, y'all. I'm going to end this. Thank you. As soon as I figure out how. All right. Bye, y'all.